Once we have our observed and expected numbers, we just plug them into that formula for each row and then sum up that last column to get our final piece of evidence. And there it is. Our calculated chi-square statistic is 1.6315. This one number neatly summarizes the difference between what the company expected and what we actually saw. But the big question is 1.6315 a big enough number to be suspicious? So to make our call, we compare our statistic to something called a critical value. Think of it as a line in the sand. Based on our significance level and degrees of freedom, that line is at 7.815. Our number 1.6315 is way smaller than that. It doesn't even come close to crossing the line. This means we don't have enough evidence to call shenanigans on the company's theory. We fail to reject the null hypothesis, which is just the statistician's way of saying the data seems to fit the theory just fine. But hang on, let's take that same sample of 140 car orders, but this time, let's ask a totally different question. This brings us to our second case. Okay, so in this case, we're throwing the car company's theory out the window. We don't care about their specific percentages. All we want to know is, are all these colors basically tied in popularity, or is there a clear favorite? We're testing for a uniform distribution. So our competing stories have changed.